Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on theory of numbers, lecture number 32, in which I will discuss system of linear congruences in two unknowns. Now we define system of linear congruences in two unknowns. Let us consider x and y be two unknowns. Then two congruences in two unknowns x and y are written as ax plus by is congruent to c modulo m, a prime x plus b prime y is congruent to c prime modulo m, where a, b, c, a prime, b prime, c prime are integers with m greater than 1. Now we prove a theorem. Theorem is the system of congruences ax plus by is congruent to c modulo m, a prime x plus b prime y is congruent to c prime modulo m, has a unique solution modulo m given by x is congruent to d bar under bracket b prime c minus b c prime modulo m, y is congruent to d bar multiply under bracket a c prime minus a prime c modulo m, where d equal to a b prime minus a prime b and d bar be the inverse of d modulo m. Now we prove this. Prove. Let ax plus by is congruent to c modulo m. This is number 1. And a prime x plus b prime y is congruent to c prime modulo m. This is number 2. B, two linear congruences in two unknowns. Now multiplying 1 by b prime and 2 by b and then subtracting, we get a b prime minus a prime b x is congruent to b prime c minus b c prime modulo m, implies that, let this is d, x is congruent to b prime c minus b c prime modulo m. Let this is number 3. Now multiplying 1 by a prime and 2 by a and then subtracting, we get a prime b minus ab prime y is congruent to a prime c minus ac prime modulo m. implies that a b prime minus a prime b y is congruent to a c prime minus c a prime modulo m implies that this is d dy is congruent to a c prime minus c a prime modulo m. Let this is number 4. Let dx is congruent to 1 modulo m be a linear congruence if d bar be the solution of this linear congruence, then d bar is said to be inverse of d modulo m. Let this is number 5. Therefore, d bar congruent 1 modulo m. Let this is number 6. d bar x congruent to x modulo m. This is number 7. Multiplying both sides of theory by d bar, we get d bar x congruent to d bar under bracket b prime c minus bc prime modulo m. This is number 8. From 7 and 8 we get x is congruent to d bar b prime c minus bc prime modulo m. This is 9. Now let dy is congruent to 1 modulo m. Let this is 10. Similar to the solution of 5, we get that d bar is the solution of 10. Therefore, d bar is congruent to 1 modulo m, implies that d bar y is congruent to y modulo m. Let this is number 11. Multiplying 4 by d bar, we get d bar y here is congruent to d bar a c prime minus c a prime modulo m implies that y is congruent to d bar a c prime minus c a prime modulo m. This is number 12. Therefore, 9 and 12 give the solution of two given linear congruences. Now we verify uniqueness. Using 9 and 12, we get ax plus by. Here, in place of x, we use this result 9, and in place of y, we use this result 12, and we get this modulo m. Now, d bar be the common, and after calculating we get a b prime minus a prime b c modulo m. This a b prime minus a prime b is d, c modulo m. Since d bar is inverse of d modulo m, so here we may write 1. So only remains c. So ax plus by is congruent to c modulo m, which is same as 1. Again, using 9 and 12 in a prime x plus b prime y. In place of x, we use 9, and in place of y, we use 12, and we get this. Here d bar is common, and then we get a b prime minus a prime b multiply c prime modulo m. This a b prime minus a prime b is d, and d bar be the inverse of d modulo m. Therefore, in this place we may write 1. That means remains c prime modulo m. Therefore, we get a prime x plus b prime y is congruent to c prime modulo m, which is same as 2. So, our solution in 9 and 12 are correct. Now we solve a problem. Solve the following system: 5x plus 7y is congruent to 3 modulo 4. 2x plus 3y is congruent to 1 modulo 4. Here ax plus by is congruent to c modulo 4, and here a prime x plus b prime y congruent to c prime modulo 4. Here in place of a 5, in place of b 7, in place of c 3, and m is 4. A prime equal to 2, b prime equal to 3, and c prime equal to 1, m equal to 4. Since d equal to ab prime minus a prime b equal to a means 5, b prime is 3, minus a prime is 2, and b is 7, that is 1. Now let dx is congruent to 1 modulo 4 be a linear congruence. Its solution d bar is the inverse of d modulo 4. Let this is number 1. Putting value of d in 1, we get d is 1 multiply x is congruent to 1 modulo 4, implies that x is congruent to 1 modulo 4. Therefore, solution is obtained. Hence, d prime equal to solution is 1, d prime equal to 1. Now, solution B. X is congruent to b prime c minus b c prime multiply d bar modulo m. This is congruent to d bar is 1, b prime is 3 and c is 3 minus b is 7, c prime is 1 modulo 4, m is 4, congruent to 9 minus 7 is 2 modulo 4. This implies that x is congruent to modulo 4. This is one of the solutions. Let this is number 2. Again, y equal to d bar multiply a c prime minus a prime c modulo m. This is congruent to d bar is 1, a is 5, c prime is 1 minus a prime is 2 and c is 3 modulo 4. This is congruent to 5 minus 6 equal to minus 1 modulo 4. For positive remainder, we may replace minus 1 by 3. This is congruent to 3 modulo 4. This is y is congruent to 3 modulo 4. This is number 3. Therefore, 2 and 3 are solutions of the given linear congruences. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.